Hey everyone, and welcome back to The Explainer. So, I want you to just take a second and think about where you're sitting right now. Earth is, well, it's comfortable, right? It's safe, we've got a nice, predictable orbit, standard weather, and a stable, life-giving atmosphere. Honestly, it kind of feels like this is just how planets are supposed to be. But the moment you leave our cozy little cosmic backyard, things change dramatically. Out in the deeper cosmos, the universe isn't just strange, it is deeply, deeply unsettling. And today, we're leaving that safety behind.
So that begs the question, what makes a planet truly disturbing? I mean, is it a toxic atmosphere, insanely extreme temperatures, or is it something far more chaotic, something that just completely shatters our fundamental understanding of how a planet should even behave? The cosmos is literally filled with anomalies that completely defy our earthly logic, and today, we're going on a cosmic safari to answer exactly that.
We're drawing our insights today from a really brilliant compilation by a creator named Joost, who set out to catalog, as he puts it, 5 exoplanets that are quite unusual. And frankly, unusual is a massive understatement here. These are worlds that push the absolute boundaries of physics and totally challenge our perception of reality. Okay, let's dive into this.
Here's our flight plan for this explainer. First up, the universe's most disturbing planets. Then, blinding light and bleeding skies. Third, storms of rubies and sapphires. Fourth, rings larger than Earth's orbit. And finally, the rogue system wanderer. So buckle up.
Starting off with Section 1, the universe's most disturbing planets.
To really give you a sense of scale for the absolute madness we're about to see, let's look at the baseline. Normal planets, like ours, have predictable orbits, standard weather, and stable atmospheres. It's boring, sure, but quite frankly, boring keeps us alive. Compare that to the disturbing exoplanet characteristics we're tracking today. We're talking system-crossing paths, clouds made of precious gem material, and skies that literally bleed into the vacuum of space. It just highlights perfectly how wildly unpredictable the universe actually is compared to our tame little globe. Which brings us to Section 2, blinding light and bleeding skies.
Our first anomaly is a planet that functions essentially like a colossal cosmic mirror. It reflects almost all the light from its star right back into space. Real-world discoveries like the ultra-hot Neptune LTT 9799b do exactly this. I mean, imagine an environment so extreme, so inherently hostile, that it bounces nearly 80% of starlight away instead of absorbing it. The blinding mirror-like intensity of this world means that if you were to look at it up close, it would be an incomprehensibly dazzling and honestly terrifying experience. It's literally a world actively rejecting the light of its own sun.
Now, what's really interesting here is the violent fate of our second disturbing exoplanet, the Bleeder. This is much like the famous exoplanet Gliese 436b. Because it orbits far, far too close to its star, the extreme conditions trigger a violent process known as atmospheric stripping. And the horrifying result? The planet is continuously losing its atmosphere into the void. It is a dying world, leaving this massive, bleeding, comet-like tail of its own sky behind it as it travels.
Moving right along to Section 3, storms of rubies and sapphires.
You hear the phrase rubies and sapphires, and you probably think, wow, that sounds incredibly beautiful. Well, the reality is pure atmospheric nightmare fuel. On Earth, we have a very forgiving water cycle. Water vapor clouds form, we get gentle rain, it nourishes our crops. Great. But on this third exoplanet, which is a lot like the observed gas giant HAT P7b, the extreme weather is almost unfathomable. The clouds aren't made of fluffy water vapor. They're actually thought to be made of corundum, which is the exact same chemical material that forms rubies and sapphires. So you aren't getting a gentle spring shower here. No, you are getting razor-sharp, superheated liquid gem materials swirling violently in an alien sky. It's a stunningly gorgeous concept, but an absolutely lethal reality if you were ever caught in that storm.
And that leads us to Section 4, rings larger than Earth's orbit.
This fourth exoplanet, widely known to astronomers as J1407b, features a colossal ring system that will just completely recalibrate your perception of scale. When we think of planetary rings, we immediately think of Saturn, right? Which is spectacular in its own right. But these rings, they are larger than Earth's entire orbit around the sun. Just let that sink in for a second. If you took this planet and placed it where our sun is, its rings would extend past where you and I are sitting right now. It completely and utterly dwarfs anything seen in our own solar system. It takes a standard planetary feature and turns it into a structure of staggering, frankly horrifying magnitude.
Finally, Section 5, the rogue system wanderer.
So planets are supposed to stay in their lane, right? They orbit in these nice, neat, predictable ellipses. Well, not this one. If we map its chaotic journey, much like the extreme eccentric orbit of the real-world planet HD 80606b, we see that in its first decade, it begins its dive from the freezing outer edges of its system. By decade 5, it goes fully rogue, crossing right through the inner star system, essentially playing cosmic bowling with whatever might be in its way. And by decade 9, it completes the entire system crossing, only to eventually swing back and do the whole shebang all over again. Every few decades, it sweeps through its star system like a giant, wildly unpredictable pendulum.
So the crucial point here is when we compare our stable Earth orbit, staying in our lane, safe, entirely predictable, to this wanderer that crosses the entire system every few decades, it serves as a massive reality check. We are incredibly lucky for the boring predictability of our little blue dot. If we had a wanderer swinging wildly through our solar system every 50 years, life as we know it would almost certainly be entirely impossible.
Now you might be wondering, how can we even visualize these mind-bending worlds since they're light years away? Well, the source material from Joost utilizes Space Engine Pro. It's a virtual universe simulator available on Steam, and it's used to create incredibly realistic CGI visualizations of these anomalous planets based on the actual astronomical data we have. It's pretty amazing that the exact same gaming platforms where people play casual video games are also hosting simulation tools powerful enough to help us grasp the sheer terror and awe of actual astrophysics.
Let's move to our conclusion here, because the fundamental truth of this explainer is crystal clear. The universe is just far more chaotic than our safe little home. Everything we've seen today proves this beyond a shadow of a doubt.
Let's quickly lock in what we've learned on our cosmic safari today. We saw the reflector, which turns away almost all starlight. We have the bleeder, continuously losing its precious atmosphere to the void. We survived the jewel storm with its beautiful but absolutely lethal clouds of ruby and sapphire material. We witnessed the mega ring, a system impossibly larger than Earth's orbit. And finally, we tracked the Wanderer, completely defying orbital logic to cross its entire system every few decades. These are the wildly extraordinary anomalies that cement just how incredibly bizarre our universe truly is.
Which leaves us with one final, lingering question. What other terrifying anomalies might be simulated in Space Engine Pro? Or, more importantly, what else truly exists out there in the dark? The 5 we've looked at today, they are just scratching the very surface of what astronomers are finding every single day. The cosmos is vast, dark, and wonderfully terrifying. Keep looking up, keep asking questions, and I'll see you in the next explainer.